All right, what's going on, guys? Just wanted to bring you a video about VFD wiring. All right, so I'm inside this air handler, pretty large unit. Right now, this is the mixing section of this air handler. Through here, let's see, those are my return fans. Got 6 fans on the return side, 6 fans on the outside. And as you can see, we got a bunch of dampers with actuators. So there's a sequence for economizer. You know, we can close those dampers, and we can open some dampers right there to essentially run 100% OA or modulate as need be. But this is the mixing section, so airflow will be going this way through the air handler. But you know, I got a lot of drives on this roof, a lot of big equipment. But all kind of using the same drive. This is a TR150. Typically you'll see these for air side. So blower motors, you know, water source heat pumps, air handlers, condenser fan motors. They might have another drive that kind of looks like this, maybe a little bit larger, that they'll use for compressors. And then you'll kind of step up from there depending on capacity to the TR200. But this is essentially our panel for the return VFDs. There's another panel on the supply side that has 3 drives for 3 motors, and then another 3 drive panel for the other. So as you can see, we got high voltage coming in, fused to our main terminal block, and then we're stepping that, you know, we're breaking that apart, and each one of these fuse blocks is feeding a drive. Okay, but just wanted to go over in terms of start stop circuit and safety circuit for the drive. You know, I'm still kind of learning a lot of stuff. This is a big step up from where I came from. But the diagram itself, if you follow it, it's pretty easy to navigate. You know, when you first get up here, you got different terminal blocks everywhere. You got isolation relays, high voltage. So, you know, at first it can be pretty overwhelming, but if you break it down, it's really not too bad. So that's what I'm gonna go through. We're gonna go over the wiring diagram for start stop and understand the safety circuit for this VFD in this application. So TR150, 3-phase coming in to the drive. This is our plug for communication. In this case, there's a central BMS that will be talking to this backnet. So it's going to have, you know, a MAC address, device ID, backnet instance number, and then set your baud rate. We have digital input on 18 and 27, and on 12, this is actually 24 volts VDC coming out of the drive. All right, and then 53 and 55 is our analog input speed reference. So in this case, they're talking to this drive and sending it a 2 to 10 sig, and then that will then scale to our, you know, minimum motor speed, maximum motor speed in between that 2 volt to 10 volt DC input. All right. So on our digital inputs, we have 18 and we have 27. All right. Got a 6-fan array, but essentially everything's the same, right? You know, they have they're just daisy chaining comm, right? And then they're sending a 1 speed signal, and then that speed signal is then just jumping to each one, right? So we're ramping these things up at the same speed, same time. So we have an input on 18 and 27, all right? So 18, we typically set up as start or run. And then 27 will typically be a safety circuit. All right, and then 12 is 24 volts VDC coming out of the drive. All right, and then we have a factory terminal block right here, factory supply quad relay. This is for start, stop, and then this is a field installed quad relay for safety. So we have 6 fans, right? So 6 start stops, 6 safeties. So let's see, let me get a screwdriver here. So here is our wiring diagram. All right. So VFD-A is that first drive. So if we look here on terminal 12, 24 volts, 24 VDC is coming out on 14A. Okay. So we're sending that voltage two different ways, right? But we'll start with our start stop. So K1, that's going to be this relay here, right? Start stop, K1, or contact one, yeah. All right, so 24 volts VDC is coming out on 14A, and then it's gonna hit this connection point here, 1TB13.4. And then from there, it's going straight through, and it's gonna sit on contact 5, right, of our relay. So if we, sorry, my video cut out, but let's say, if we follow, all right, 14A, and if we go to 1TB13.4, that's going to be that wire, and then we're passing through to 5. All right. So 14A, all right, from the drive, coming down, and we're going to sit on 1TB13.4. Here we go, 1TB13.4. Here's that wire. All right. As you can see, we're sending it two different places. We got wire going there, and then we also have a jumper. All right, but one of these wires is coming from that drive. Oh. All right. Now, that connection point is then going to be sitting on contact 5. All right. You can normally open contact here. All right. And then we see a note here, 6. Closes to run auto mode or bypass auto for option VFD or starter. All right. So let's find this. 1TB13.4 going to contact 5. All right. So as you can see, if I pull on this one is going to the drive, this wire right here. We have another wire here that if I pull down, all right, that wire is coming and sitting on 5, all right? Normally open contact, okay? So when BMS closes this relay, all right, 24 volts or whatever this is, what's the coil? 120 volt coil, all right? So they're gonna close this, and then they're jumping this too, right? We just have 6 motors, so we got 4 on one relay, 2 on the other. All right. So when they close that, 5 is gonna close to 9, and then that's gonna go straight through, sit on 1TB13.5, and then go to 18 as a input. All right. So boom, they close this. 24 volts VDC will pass through 18A, all right? And then we're gonna go to 1TB13.5. 1TB13.5, all right? So you see we have nothing on this end, but we're gonna pass through to this wire right here, all right? 18A. And then it's just gonna close 24 volts VDC, 12 to 18 for start stop. All right. So that's the circuit right there. Okay. Now we have an input going to 27. We have a wire on 27. Okay. So 27 we're going to set up as our safety circuit. So we're going to have 24 volts DC from 12, right? And we're going to be sitting that on 1TB13.6, all right? So let's find that wire. So 27, right? 19A. Or actually, let's find this. We'll start from power, all right? 1TB13. Was that a 6? 1TB13.6, right? So here's 1TB13.6, right? Remember, we were jumping power. This is from 12. Yeah, terminal 12, all right? One's going for a start stop, and then this wire is just a jumper. So we're gonna have 24 volts sitting right there, right? And, all right, and here's a field installed wire, right? So we know we got power sitting there. So we have a note here, right? Right where it says W10, note 9. Remove jumper and installed field safety interlock. So between 6 and 7, there used to be a factory jumper, okay? 6 and 7, there used to be a factory jumper there. But they now have, we're essentially using this quad relay as our closure, okay? So if we follow that wire, we're going through that. Now it's a normally open contact. Straight through to 27, all right? So power is gonna sit here, go through our black wire, all right? Let's see which one it is. I guess I'm this one right here, all right? 24 volts VDC will pass through, right, to our out, all right? Now this is their safety, right? So essentially, from their control panel, they'll be closing this relay, which is ran series through, you know, high static, freeze stat, leak detection, etc. Right? So if all those are closed, we will be energizing our coils here and passing through, right? We're just isolated. Our voltage is isolated with these contacts, right? Just like we are here. Isolated, 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 all right? So 24 volts VDC will be sitting here, right? Now we're coming out, okay? Then, for instance, we're coming to our 7. Then we're coming straight through and we're touching 19A, okay? So if you can see here, we're going right through to 19A into 27, all right? So 19A, all right? So when we have closed safeties, boom, coming in as 19A. So we have 24 volts DC touching between 12 and 18. 24 volts touching from 12 to 27. This drive will run, okay? If we have an open on our, you know, our high static, whatever, we will not have a closure on this relay, and therefore we will not have a closure on these contacts. So it will not have 24 volts hitting 27. In this case, we will program these drives as a coast inverse, so it's just to come down to a stop, right? It'll have start stop, but we won't have an input on 27. And that's pretty much it. I mean, and as you can see here, let's see. So, number 9, right? Number 9, remove jumper, field install lock, yes. Well, let's say here, 5, right? Look, note 5. Program terminal 27 as inverse coasting stop. So if we don't have an input on 27, the drive will ramp down, the motor will come to a halt, right? Or it won't start. And then as you can see here, what does that say? Note 4, program terminal 18 as run. Yep. So that's pretty much it. And it's got some extra features here, right? So we have a couple extra external relays, factory provided. So we can see here, we have a normally open contact between 4 and 5, and then 4 and 6 is normally closed. So we can use this as drive, run, sig. So essentially this can be a status, right? So let's just follow this just because. We got a wire sitting on 1TB1355 and 1TB1320. All right. So 1TB1355, we got a wire here, okay? And then what's the other one? 1TB1320, 1TB1320, so it's right here. All right, as you can see, we don't have a wire We don't have a wire on either one. So this could be used as a closure, as a binary input to their controller that our drive is running. But in this case, we're using CTs as that closure. So essentially drive is running, CT input back to their controller, right? So that's pretty much it, I mean, all the action for the drive is right here. All we're concerned about is the wires in the drive, right? This high voltage is easy, right? 3-phase coming in through fuses, coming into the drive. Drive's doing its thing, UVW out, right? That's that. All the action is right here, and it just goes about breaking it down, right? Understanding, hey, our control voltage is isolated, right? We got isolation on our safety. We have isolation on our start-stop. Other than that, that's it. So it's like, hey, drive isn't service call. Hey man, my drive's not running. All right, let me go check a look. Hey, I got start stop, but I don't have input on 27. I can look through the parameters and I can see, hey, we're set up for coasting, inverse coasting stop, right? We're not getting 27. We're not getting 24 volts on terminal 27. Well, what's breaking that? Safeties, freeze stat, leak detection, and then you just go from there. But I've been just, like I said, I just take my time with it. I'm still learning a whole lot, but when you break it down, follow the wiring diagram and just say, hey man, let me take a look at it first and I'll get back with you. They obviously want it fixed as fast as possible, but take your time. That's what I do. I'm not in any rush. So hopefully that helps some people understand in terms of diagram for this drive, right? This is a pretty basic drive. Internally, these drives, the next drive up, you can program this however you want. There's all types of features, different parameters, etc. But for the basic start, stop, and safety circuit, that's how it is, right? That's how it's handled. So hopefully this helps. And here, I'll just show you just because, right? So as you can see, let's see. So take a look here. All right, so this is start, stop, that's safety. So pretty much, for instance, this is an analog SIG in, right? So as you can see, we're passing through, right? So this is a speed input to one drive, right? Then we're just jumping, boom. All right, speed input to another drive. Now we're jumping, boom. All right, speed input to another drive, boom. Speed input to another drive, etc., right? So if you just follow that, right, our DC SIG is just jumping. Whoop, whoop, whoop. So that's that, but so hopefully that helps, and I'll talk to you guys next time.
Hey, what's going on, guys? Just wanted to continue on this video regarding this wiring, and I noticed as I was watching it back, I said that they had energized these relays for start stop with 120 volts, and it got me thinking. I was like, I don't know if their BMS is sending that. I think they're sending 24 volts, right? So I've already started up a handful of panels already with some of these that have these quad relays. These are factory installed, right? And I was like, I don't know if they're sending 120 volts through these wires because this is just shielded. It's like 18 gauge stranded, right? So, and here's our safety, 24 volts AC, right? And I was like, huh, interesting. So I go walk around the job site and go to the air handlers that have, similar panels. Essentially, they were built outside of, the actual air handler factory and then just mounted on it. And I'm gonna bring up another drive panel that I already started. And as you can see, 24 volts. This is that same relay for start stop. In this case, it's a 3-fan array. 24 volts AC. And then this is our safety, right? 24 volts. So this is the coil. So their controller is sending 24 volts to close this for safety, right? Wired through the safety circuit. And then they're also sending an output from their controller for start stop. 24 volts AC though. So I actually called the manufacturer of the that built this panel, and they confirmed with me that they indeed just picked this relay wrong. Both of these quad relays should be 24 volts. So, instead of waiting for them to send me that, I went ahead and went to Airco. I picked up 3 2-pole IDEX and bases, and I just essentially wired, one relay A and B VFDs, second relay C and D, third relay E and F, and it's all good. So, and then they kind of did the same thing, parallel the coil voltage. So, just wanted, yeah, I didn't catch it on while I was doing it, but it's just funny, it's just one of those things that just happened to, do a double take. I was like, huh. So, anyway, just wanted to go over that and talk to you guys later.